Alright, should be another DraftScience, a video presentation. DraftPhysics.com and such. Anyway, so I'll do a response video to, this is some Furball guy. Can't remember the name, something like that. Anyway, not too many views, kind of better looking than the average physicist. Has a nice little room full of physics-y kind of stuff. I had a little Saturn rocket and telescopes and howitzer. I don't know exactly what that is. Globe up there and lava lamp and blah blah blah. Anyway, just this whole physics presenter thing. So this is another case where sort of demonstrates YouTube's complete fail. How Google just absolutely has screwed the internet and its function. Because frankly, this guy's better than a lot of the physics presenters, and the physics is horrible. But I just mean, as presenters go, it's much better quality, and just videos have less than 1,000 views. So just an example how the internet just isn't working. I was trying to find a listing of YouTube physics presenters, or even just. I know I could go to a less specific category of science, but really is physics is the one that's important to me. But anyway, and you really can't search for it. I mean, there's no search function that works. There's no filters that work. So if somebody knows how to get a good listing of, where the highest amount of subscribers, all the way down the list kind of thing of people talking about physics, because you really can't find anything. I mean, I get a list that doesn't even have Veritasium on it, right? He's got like 7 million subscribers, and he doesn't show up on the subject of physics. It's just too stupid. It just sucks. My purpose is to try to see how many of these people I have on the list, see if there's somebody else I can contact to see if they want the $1,700 to, let's make it $2,000. Hell with it for Christmas. $2,000 just to play my video and explain how I'm full of shit. The two-slit video. So anyway, just irritating. So this conversation is mostly going to be about relativity and redshift and, just all the wrong assumptions. And he has a nice speech at the end, and I don't know if I'll get to it in this video, so I might have to play that in a separate video. Just about how can you doubt our physics? It's just so super, which is quite pathetic. But anyway, without further bullshit, I guess, leave us play the video.
We live with the effects of gravity.
Okay, well, that's not enough volume, so I have to fix that first. Probably.
Not density, constantly and on a daily basis. It's the
Yes, it is amazing. It is there all the time, and you'd think by now we'd have a real theory of it, instead of some notion that some space thingy is bent by the matter stuff fish, with some kind of consequence that it means there's a vacuum cleaner inside of everything, and it's sucking space or something like that. I mean, if you had to explain this to aliens, and you'd have to just be watching, and then they'd just start laughing. I mean, that's the best you idiots could do? Bent space? Oh, they would just be like, oh, facepalm, why am I even talking to these assholes? Let's just blow them up. Too stupid. You call that physics? Oh, no, we call that, over there on Alpha Centauri, we call that magic and religion. We don't call that science. Bent space.
force that secures our positions firmly on the Earth and holds the atmosphere down. But how does it affect light, and can that be observed by us mere mortals?
All right, how does it affect light, and how can that be observed? You would think so. Light's pretty observable, right? I mean, that's how we see is because of the light, and if it gets bended, we should be able to tell.
Today we're going to take a look at one of the most ingenious experiments ever devised to test Einstein's theory of general relativity.
Okay, so that's a bit of hyperbole. Okay, a bit of an exaggeration. It's not all that brilliant, and it's, blah, blah, blah.
So let's talk about Pound and Ribca and the gravitational redshift.
Let's talk about a 1959 experiment that apparently hasn't been repeated with any modern technology, and using something other than, impossible to measure really gamma rays. But anyway. So I don't know what all this crap is, but very fine. Great, yes. Now, this intro is just silly and long, and so I really don't get the point. Yeah, I'd speed it up, but this, I'm just going to make a mess if I try to advance the video, so no point in doing that. But what is this? What does this have to do with anything? I have no idea what these icons could possibly mean. I don't know what the hell this is. So, BM Furball.
But before we get to the experiment...
Sounds kinky, frankly. But anyway, go ahead. Continue. I don't know why this asshole's still sitting here moving pancakes, but whatever.
We need to understand the phenomenon that's being tested. The shifting of wave frequencies due to external influences.
Right. So the difference would be, we know that the emitter and the receiver can screw it up by moving. So I can move away from you, right? I'll reflect less light, and I'll reflect less sound, and I'll reflect less everything because I'm moving away. And so, yes, the pitch will change, just even reflected sound. If I'm moving away from you, I'm going to change the reflection. And the same is true when you're receiving and emitting. If you're moving, you're changing what's happening because you're changing the distances. Stuff is traveling before it hits you, and it's just such an obvious thing. Now, this idea that stuff can get shifted on its pathway, well, there's only two ways that could happen, right? Magic, space just fills voids and expands things, or this stuff has to hit something, and when it hits something, it gets redshifted. That's the first thing that could happen. What's the first thing that happens when you hit something? Oh, you get slowed down. You're occupied for a minute, right? It's not even that you're slowed down, right? Let's say you're a little fast jogger walker, and you walk, and you hit a telephone pole. Well, what happens? Oh, you don't move for a little bit, but then you go right back to work, like nothing happened. But you still lost some time, right? That's physics.
In everyday life, we observe sound waves being shifted due to the relative motion of objects and the observer.
Well, why don't we say the emitter and the receiver and get rid of this stupid observer word, because it implies you're observing without any consequence, like you're magically observing, like somehow you have magic vision and you can see everything instantaneously and all of that stuff. See, that's really bad physics again. If you went up to the aliens and say, "We observe things," they'd say, "Oh, no, you don't really do that, do you? I mean, you have to wait for the light to get to your eyes like all the rest of us, don't you? So that's just kind of bullshit. You receive things and you emit things. That's what everything in the universe is doing. See, and that's what gravity is, right? Gravity is stuff goes in and less stuff comes out. And that's why you fall into things. It's because there's less stuff on the inside of stuff coming out than there is stuff going in, because it's hitting telephone poles. It's getting delayed, and that delay adds up, and it equals gravity. There, simple answer. Problem solved. We don't need any woo. Oh, God, this is so tedious. Why are you all so goddamn stupid? And then you're belligerent about it. Belligerently stupid. I will stay stupid and I will not be educated, especially by you, because you're not one of me. You're not part of my club.
This is known as the Doppler Effect. A common event for this observation is a train on tracks or an ambulance passing by. The relative motion of the object as it approaches causes the waves to compress and get higher pitched.
Yes, it causes them not to be able to advance. Yes, because the ambulance keeps pushing into them before they can get where they're going. Oh, yes. Yes. So they end up piling on because one piece gets pushed by the ambulance, and then the next piece, it's supposed to be allowed to just go its distance. Well, the next piece gets pushed forward because the ambulance is pushing eliminating some more distance. And so now the waves don't have the full distance between them because you keep pushing new ones as you move. So as I've made this argument, this is so fundamental to physics. This is everything to physics. If you just thought of us, I mean, these are people that believe in an ether, right? You people are supposed to believe in this ether stuff. Well, the simple answer is when you're moving into the ether, you're pushing more of it. And when you're moving away, you're pushing less of it. And that's so simple to understand. Why don't you just understand it that way? That every bit of movement, okay, causes a compression or an expansion of the goo you say we exist in. Now, I say the goo is made out of stuff moving the speed of light, and it's, it's in bits, and, you can control the little bits, but whatever.
And as it drives away, they expand and become lower pitch.
Right, but they don't expand. The waves don't expand. They're produced and they're received. Okay, so when they're in space, they can be just fine. But if I move into them, then all of a sudden the pitch is going to go higher because I'm receiving a wave. And, it's like I swam into the ocean waves, right? I'm going to hit the waves at a higher frequency because I'm moving into them. Okay, what's complicated about understanding that I didn't change the wave? I'm changing how the wave's being interpreted by moving into it. By not staying on the shore, by moving into the waves, I'm increasing the wave frequency. And if I was to be able to do the opposite and move away from the waves, then the waves would get to me less regularly and the period would be changed based on how much velocity I was moving away from the waves coming. And that's the simple answer for what Doppler shift is. Any other shift now has to be explained in that context.
And just like sound waves, Einstein proposed in 1915 that...
Einstein said lots of stuff, but let's remember what he said, 2 years before he died. I have been studying the photon for 50 years, and I have not improved my understanding one iota. So let's understand, Einstein was not at all satisfied with this theory. He did not think any of this was complete or done. He wouldn't be making these videos. That's the frank truth. He wouldn't be making this style of video. He would be saying, well, this is what the evidence is, and we still really just don't have a complete answer for why this is happening and how this is happening, because frankly, the answers we've provided are a little bit empty and vacuous. They don't, they're not good answers. Magitons and wavicles and all of this crap just doesn't sound like very good physics. And I really wouldn't want to have to go to the alien planet and represent our physics and say, well, this is our theory of reality, and have to explain this horse crap because it seems way too frickin' full of mush. You think Einstein would go to the aliens with where we have this theory of the dark matter, it's invisible to everything except it makes the magical gravity. No, I don't think he'd want to do that. I think he'd be embarrassed to have to do that.
Light waves could be compressed or expanded by outside factors as well. Over the past century, this shift in wavelength...
Yes, they could be affected by... The only thing that can affect them, though, is there has to be a particle. There has to be an electron. Some sort of material thing has to interfere because light is a frickin' force. It's moving the speed of force. Another thing that, would you really want to go to the aliens and say, well, it's the speed of light. That's it. That's all. Light. Fuck everything else. No, I don't think you'd want to do that. I think the aliens know full well it's the speed of all the forces. So all the forces have to be made out of this stuff. And we know this stuff just doesn't interact with the stuff. The force will not bang off of the force. Your little lightsaber bullshit, it ain't going to work. You're not going to be able to bang the force into the force. You have to bang the force into matter.
It has been observed in several different ways, but mostly through the observation of stars. But let's take another step back to understand the photon and how it...
So again, what we've observed in stars is the fact that they got a redshift, but we don't, there's no proof that it's Doppler or this or that. There's just, all we can do is reason. And I'm saying the reasonable explanation is, well, the faraway objects are more redshifted by reliable percentages, so therefore we could come up with the conclusion that maybe there's something about the space that the photon has to travel through that's frickin' wearing the light down.
What actually obtains its wavelength that we're measuring. When an atom from any element has energy added to the system, electrons can be elevated to the next higher orbit.
See, this is good, okay? This kind of understanding that there's a kind of movement that electrons have, right? That they can move a little bit, you know, or they can jump. You know, they can make a movement that's a bigger jump. So I would analogize it to, this looks a little bit like a magnet. Well, this is sort of like, you know, the iron filings could be jiggling in that little row. And then, you know, if I gave one a little bit of energy and I pushed it out into the empty space, it has to commit. You know what I mean? It either goes back or it goes forward. But it can't do either one. I mean, it can't be, those are the two choices. And the point is, if it goes forward, you know, it's going to have enough momentum, it's going to keep its momentum, and it's going to keep pushing. And so the idea sort of is, I mean, obviously it's not a direct analogy, but that jump is very quick, okay, and that it's a good enough distance where you're changing the universe enough, right? So if I move towards you at the speed of light, but I only moved, you know, whatever, a microparsec thingy, you know, just the tiniest of little distance, I can't change the field much in front of me, right? I can't push much of the atmosphere. I can't push photons. I can't push anything. But if I move a distance towards you at the speed of light, I would collect all the energy that was moving the speed of light towards me, all of it, and I would compress all of it into one big boom. Okay, a big boom would hit you of energy, because it wouldn't hit you here, 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 here. No, it hit you all at once. I'd collect all of it and send it as a reflection all at once. So you'd see the light that's hitting me for all of this time, right? I could count it 1 second or something and say, oh, there's a certain amount of light that hits this surface. Well, if I move the surface, then I take that entire time that it took to move that surface, and I take all of that light, and I send it to you all at one instant. You know, and the same thing happens if I go in the opposite direction. Then you get this effect where I turn invisible, because eventually I'm going as fast as the force can reflect, and that means the force never reflects. It never catches up to me to bounce off of me. Just as the wave on the shore, I can run away from it and it never catches me. It never bounces off of me. It never knows I exist because I ran away from it. That's the simple model to understand that when that electron moves, it's going to reflect its universe. The universe is shining a light on it. Gamma rays, all kinds of energies hitting it. The gravity, okay, that's real energy in the universe. All that stuff sitting there hitting it, and it's pushing into it. So it's going to collect all the stuff that would have hit it in a little while. Well, it's going to hit it now sooner because it moved into it. And it's going to take the stuff that hit it a little while ago, and it's going to send it at the same time it's going to send the stuff right now. So it's collecting a bunch of energy by moving, and then it's going to, when it stops moving, that energy is all going to be going at in the same pile of space. So it's going to take energy that was filling this much space, and it's going to compress it into a space this big. And that's something we can detect. Now, a single photon can't, a single electron moving can't create a whole photon, because a photon is polarized, and it's gigantic, sort of gigantic in terms of its spatial dimensions. So obviously a component of the photon is created when that electron does that. And then in some other atom, the same thing is happening at the right time. And so that creates the second wave, the second push into the environment, the second little extra reflection that's going to fly out into the universe. And that's when you have a photon. That's the simple answer. That's the right answer. Just quit pretending that this wooey crap is right.
On the atom.
Ugh.
These orbits are very specific in value. You could almost view them as...
Yes, view them as magnetic positions because they're being controlled by charge, okay? They're a charge phenomenon. The electrons are stuck in a position. They hate each other and they want to get to the proton. As I've explained so many times, you can arrange magnets where this very phenomenon happens. I can just take two pieces of glass and I can put magnets in there and I can have them in tension where even though there's a strong attractive force for it to go one way, it can't because there's two negative poles over here that are pushing against it, and that the magnets can be caught in tension. You can levitate them. You can do all kinds of things demonstrating you can put them in a position where even though there's a bunch of forces that should be telling them to go that way and all these ways, they're all balanced and it's just stuck in a position. And that's what an atom is.
Steps on a staircase. Electrons can only go up exact numbers of steps, and require exact amounts of energy to do so.
So, and again, they have this backwards, but I mean the real energy is in the inner part of the atom. The outer part is the low energy part, and they think they have it backwards, because of how they're thinking about how it gets pushed and how it releases. But anyway, you release energy by moving fast, and that's all. And it's just obviously you have to release it out for us to get any of it. If you're moving towards the atom, you can't really be pushing energy because it has to go through the nucleus then. That's not going to be good for it. But anyway.
When the excited electron relaxes back to its original state, they emit a photon.
So that doesn't happen, okay? So that's just, so he says so, they've concluded so. Single atoms make photons. So let's understand that the photon, by every possible reasonable experiment ever done, is demonstrated with overwhelming evidence. There's no such that we've never detected a photon that doesn't have polarization. That is, that can get through two polarizing films. We can't make a photon that can do that. I mean, a regular visible photon or anything even in the infrared to ultraviolet range. None of those photons can get through two polarizing film put the opposite way. So obviously none of them have zero polarization. They have polarization that is thousands of nanometers worth, which means there's at least hundreds of atoms worth of distance that the photon is traveling through in space. It's thousands of atoms worth. How can that event produce something that has thousands of atoms, and a reliable thousands of atoms? I mean, the polarization doesn't get bigger and smaller and change or do any of that stuff. It's solid. It's reliable. Okay, so the parallel path of the components of whatever a photon is clearly reliable. So again, this is, they say so. They've written it in their Bible, and it's just not the truth. And they ought to just say, well, we think, we have some notion. The evidence isn't very clear. So they should be conceding something here, and they concede nothing. And so this is a fundamental error, though. This isn't like a little error. This is fundamental because it really goes to this whole notion of when they see a photon and they're saying one atom created it. That's a real flaw in their theory. It's the flaw is not understanding that no, photons have to be created through a process you might call electricity. It has to be created because two atoms are either connected physically through a material, or they're connected by having exactly the same circumstance. Being in just the right circumstance.
Directly corresponding with the amount of energy between the two levels, or stairs. And that energy level imparts the wavelength onto the photon.
Well, what it imparts is just how many of these little bits you're compressing into space. So you're compressing a bunch of bits into space, and then another atom's going to compress, another electron moving is going to compress bits into space. And you're going to have that compression is going to hit a surface. And what it's going to do is it's going to hit it once, and then it's going to hit it again at just the right time to hit the electron that now is moving on the surface to give the electron more energy. So it's just like you poke the pendulum. The pendulum is staying down. You poke it, and the idea is you poke it again, okay, before it starts to fall. And that way you make it go higher, and it's this height that allows it to be free. And so all you're doing is adding momentum to a system. You have to add the momentum to a system based on a resonant formula, based on how the motion of the electron is swinging, and the electrons are all swinging, and it's all just about hitting them while they're moving away from you rather than hitting them while they're moving towards you. You can't add energy if they're moving towards you. You can only add energy if they're moving away from you. I mean, that's physics is so simple.
If the atom absorbs a large amount of energy, the electron jumps several steps, and correspondingly will emit a photon of higher frequency light when it relaxes.
Well, it's obviously, in some sense, it's not going to be higher frequency. It's going to be of bigger duration, because the real point is the velocity is going to decide, in a sense, the frequency. How fast it moves in will decide how compressed it's possible to make the energy. And the size of the compression and the timing between compressions is going to decide the frequency. But again, the photon is more complicated than anything that can be produced by a single atom. And me just asserting that and telling you it's more complicated than what can happen in a single atom, it should be something you can accept as a truth by just recognizing that the polarization of light makes it a truth. The fact that you can't get any photon to go through both of those filters is telling you this can't be created by a singular event in a single atom. That's just wrong thinking.
Another way photons are emitted from an atom is from inside the nucleus itself. If an atom is in an excited state inside the nucleus, it will eventually return to its base.
So again, the only thing you're trying to get out of this atom is motion, some piece moving. And it has to move quickly or there won't be any effect, right? I mean, compressing this space into this space, making this space just a tiny, tiny bit of compression isn't going to be something that's going to mean anything. So what means something is when you take space this big, the space between two electrons, let's say, and you compress that space quickly, because then you did this thing where you collected a whole bunch of stuff that was in an area and you've changed it where it all moves at once now. So all the stuff that was in this space is now compressed into this space and moves collectively. And that's what it's doing. So you can understand that when the electron's doing that, though, when the electron moves fast this way and compresses everything this way, it's doing exactly the opposite on the other side. It's taking a bunch of bits that were in this much space and it's expanding them into this much space. So there's always the anti-particle, in the sense that, yes, the photon you create going this way, you're creating an opposite on-off. You're creating an opposite compression, lack of compression on the other side. I can't move forward without reflecting less to the people looking at me from the back, and vice versa. I can't move away from you without moving towards them. And everything is in the universe that way. Everything is reflecting the universe that way. Everything is just, all the material bits are doing is reflecting the universe back to the universe. That's all a material object is doing. By moving, it changes the reflection. It applies a frequency to the reflection. It's that simple. This is so irritating.
State by releasing energy in one way or another. One of those ways is to emit a high-energy gamma ray. And just like photons emitted from the electron cloud, exact quanta of energy are...
So all it means is that you have put a bunch of these little frequencies together, right? But there has to be... It's a very tight frequency. So you're guaranteed, when it hits a surface, it's guaranteed that the pendulum hasn't slowed down much. So the difference in the radiation, right? I mean, the long waves, the infrared light, still is hitting it while it's moving in the right direction, but it had slowed down. The pendulum has slowed down quite a bit, and now it hits it. So there's less momentum. So the sooner you hit it, the faster the net total energy will be, because you haven't allowed any of the energy to be degraded. So you get the peak velocity the sooner you hit it. So obviously higher frequency will produce higher velocities.
Required to excite the nucleus and exact amounts are released with that gamma ray. There are no half steps. Each element has various electron jumps possible, but again, those energy requirements are exact. No.
So that's what you see in the fact that they can, image these different possible paths that electrons can take inside of atoms. And look, these are, who knows? Well, atoms could be, sort of like galaxies. They can be a little bit flat. They can be all kinds of different shapes. But, in a three-dimensional model, obviously there's all kinds of paths that can be, longer and shorter. So the more complex the atom gets, that is, the more dimensional, three-dimensional it is, and the more pieces it has, the more complex it gets to figure out what possible agitations, what possible path an electron can take through the atom based on pressure, based on it getting pushed, it getting hit by a gamma ray. In a sense, all of this stuff is already built in. Gamma ray has to produce a gamma ray in a sense.
Half steps are even possible.
That's why you can't destroy the energy. It's because it was already in there, so to speak.
The wavelength of the light for the photons that are released for each element.
Nothing spontaneously does this. Okay, nothing just says, I'm going to make a gamma ray. The making of the gamma ray is that two pieces of energy, a jiggle from one electron and a jiggle on this electron, actually happen at the same time, and that pushes the third electron with adding those two forces. So a weak force this way, a weak force this way, adds up to a strong force this way for the third electron. So this is how the energy is combined and reduced. So you can put gamma rays in, get infrared out. You can put infrared in, get gamma rays out, depending on how you structure your little physical device. So all of this is mutable. I can change radio waves into infrared radiation pretty easily. I can do lots of that kind of stuff.
Is known to exact detail. As photons are liberated from a hydrogen atom, the core constituent to stellar evolution, they have an exact wavelength based upon the exchange in orbits.
So again, the exchange in orbits is what's creating, part of this photon. But it's only part of it. You need it to happen more than once. It needs to happen in more than one atom for you to have something called a photon. A photon isn't just a piece of energy. It's a piece of energy in a certain condition that allows it to cause a condition in another atom, in another piece of material. Again, it can't affect a single atom. And the real point is, too, is that all of that is completely the pieces of compression, the fact that this fist moved really fast and pushed force towards you, and then this fist moves really fast and pushes force towards you. You can sort of understand, I can move this fist, then this fist, then this fist, then this fist, and create a chain of compressions. Each one of those compressions is independent of each other. They're not tied to each other, they're not connected in any way. And they can be deflected and absorbed by something moving and changing as individuals, and that would be the nature of scatter. Scatter takes the energy and breaks it into pieces, and then you can recombine the energy on the other side, so to speak.
This creates what is known as its emission spectrum. This is the spectrum of hydrogen.
So it just means these are just different path lengths that the electron can travel inside the atom. So it's different amounts of distance it can travel, and the different distances equal a different frequency that it can produce.
And this is the spectrum of helium. These numbers are unchanging by any physical phenomena within inside the atom. When mass numbers of photons are released from helium, this is what it looks like on a spectra. If you evaluate the spectra of light and you see this, you know definitively that hydrogen atoms were the source of the photons that you collect.
So all you're really saying is this is when atoms are disrupted, when they're broken. They can break in lots of different ways, and these are the specifically different ways. So the more complex the atom, the more complex the ways you can break it. But if you're just generally breaking atoms, then you break it in all of these ways. But there'll be more in some and less in others. So some of them will be very faint bars, and some of them will be very bright bars.
However, If the atom is moving away from you at the time, those wavelengths will shift ever so slightly, similar to our train.
So it's not ever so slightly. The fact is that the redshift, the galactic redshift, is huge. I mean, it's a giant shift. So it's not like it's ever so slight. Velocity would be an ever so slight because it takes a lot of speed before you can just change the nanometers. You have to have a lot of speed to significantly change the wavelength of a light reflection. And so, but the galactic shift is huge. The red shift where they see on these galaxies amounts to, on some of them, a representation that would imply they were going faster than the speed of light away from us. I mean, that's the implication of the degree of the redshift. It's so much redshift that it implies that they're going faster than the speed of light.
Due to the exact spectra of the elements, we can know that this still came from hydrogen. And by the change in wavelength, we can identify if the atom was moving towards us or away at the time of that emission. As with the train, the wavelength will get longer if the atom is traveling away from us. This pushes the spectra toward...
So again, it's not like it changes. It's that the emitter, because it's moving away, it's just a fact, it has momentum. It's making, a frequency that's going to be redshifted from our perspective, and everything on the other side of it, the place it's moving towards, is going to be blue shifted. But it's actually, the waves are changed. They're not changing in space, they're changing right when they were created. And the same is true for the receiver moving. It's going to change the waves that were. The waves didn't change, it's changing them by interpreting them poorly, by moving.
The red end of the light spectrum.
I mean, I don't change the ocean waves, right? If you drop a meteor into the water, the meteor creates the waves. That's what they're going to be. It's based on it pushing the water. But if I run away from the beach, it doesn't mean I've changed what the ocean waves were. I'm changing how I am going to interpret them.
And if it's moving towards us, then the wavelength will compress towards the blue end of the spectrum. This is known as redshift and blue shift. This can be observed by anyone pulling the spectra from stars in the sky. Even amateurs are able to do this. A second area we have noticed this shifting is by observing objects farther and farther away from our home here in the Milky Way galaxy. Using the known spectra of stars, Edwin Hubble observed that nearly all galaxies in the sky were moving away from us.
So again, he uses Hubble, and Hubble didn't agree with any of this theory. So again, this expansion theory of the universe as the explanation for the shift. I've offered the simple explanation that there are empty space isn't as empty as but they already know it's not empty, so why should they even have to make this argument? It's full of hydrogen atoms, and those hydrogen atoms will cause the light to scatter, and the scatter will end up causing even to be transmitted, the light to be transmitted. And you can just imagine the little hydrogen atoms as just being little tiny pieces of glass. And if I add up all the glass, we already know that the transmission speed of light through glass is only, is 40% less. So I've slowed the light down, and by slowing it down, I can change its frequency. Sort of that simple. But it really comes down to it's a kind of scatter. I mean, you can only you're really just breaking the pattern and then remaking the pattern, and there's a time delay in how you did that, and that's how you're allowed to take 10 bullets that are this far apart and make 9 bullets that are a little further apart. And that's really what's taken place.
Relative motion at the time of those emissions could not explain this completely, as the farther away he observed, the deeper the redshift was, meaning that the objects farther and farther away were moving faster and faster. Ultimately, science determined the reason for everything moving away from us was due to the physical expansion of the space between us.
Right, so they talk like this is really solid. They got so much evidence, you can't deny it. It's like evolution or something. Not even close, the little tiny shreds of experimental evidence. and just no real good reason to believe this extraordinary theory. So again, would you really, I mean, you people who are so obnoxious defenders, would you really want to go to the aliens with your expanding space theory? You know, I mean, would you really want to just sit there in the big theater and all the aliens are there, all the smart aliens, you know, and you're presenting your paper on the theory that the universe is expanding because we have this little shred of a glimmer of evidence? Come on. I don't think you'd want to do that, because I think it'd be really humiliating, because they're going to laugh at you.
And the farther away an object is, the more space there was to be expanding, similar to the dots on this balloon as it expands. So the wavelength of light...
You want to go to your aliens with your blown-up balloon and try to explain how the universe is a thin piece of plastic that I can stretch. Shit.
...had been stretched by the medium it was traveling on, the fabric of space itself. Now back to this amazing...
The fabric of space itself. You really think the aliens are going to sit there and buy any of this crap that space is a fabric and that you can stretch it and that it's a stuff that you can stretch and that somehow it just stretches? You don't need to apply any energy to stretch it. You don't need to do any, you know, it's just magic. You just say stretch and it stretches. Shit.
Experiment. Einstein also predicted that gravity itself could affect light, but
well, he predicted lots of crap that was just silly. I don't even know why he even bothered doing some of this crap, because it was just so bold, and you know, he just got lucky. He just got lucky that it was able to tell these silly fables, and there was some connection, like somebody actually had that name. You know, it's like he made up some silly name in the past, and it was like, yeah, somebody actually had that name, and they actually did something silly. I mean, he just got so lucky. The fake Eddington experiment, the little tiny coincidence that, yes, radioactive decay can be retarded through velocity, that the process that actually causes elements to decay is a process that you can retard by giving something velocity, because now the event that would take place can't happen as easily because it's moving into more force, and so it's not being hit by balanced force, and that's why the decay is retarded. But it's just that simple little coincidence. Boom, he's brilliant, and that's all the evidence they have. It's just that thin.
From a completely different cause. Einstein had expanded upon a principle that was established hundreds of years before, known as equivalence.
Yeah, well, it's just a retarded statement in a sense. I mean, obviously everything's equivalent, and there you should be saying, where's the energy come from? Where's the energy come from? Okay, if something's going to move from point A to point B, what's moving it? And this magical gravity force thing is just silly, because there's no energy, it doesn't make any sense, it's not physics, blah, 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 blah. But the equivalence between saying that somebody's, you know, I've already gone over this so many times, but I can take a bullet's energy and I can spread it over a whole big giant, you know, 6-foot screen, and then hit me with the same amount of energy, and I'm not even gonna, you know, I'm just gonna go, ha ha ha, ha. Oh, you hit me, oh yeah, you know, it's gonna mean nothing. But if I put the energy in that little bullet and then I hit me, oh yeah, the force is gonna bore a hole through me, it's gonna kill me, blah 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 blah. So it's just, you know, it's just how you understand that energy can be in these different forms, and gravity happens to be a perfect force in terms of it's nothing like a bullet, it's nothing like a brick, it's nothing like a telephone pole. Gravity moves you by moving you perfectly. I mean, it moves your kneecaps just as fast as it moves your elbows, just as fast as it moves your stomach and your liver and your pancreas, and so you don't notice it. It moves you so perfectly that you don't know it's moving you. And that makes it quite a different kind of acceleration or movement than being moved by being kicked in the ass.
The principle of equivalence postulates that any effect of gravity, the downward force, can be reproduced exactly through an upward acceleration.
So the joke is the upward acceleration isn't reproducing gravity, it's reproducing the Earth pushing back. You push into the Earth, you trespass on the matter below you. You're trespassing on it. You're pushing into their fence, onto their property, and they're merely pushing their fence back and saying, no, you can't go here. And it's what you're feeling isn't gravity pushing you down. You're feeling the earth pushing you back up. Again, you want to go to the aliens with this silly story that, oh yes, I feel the gravity pushing me down. And they're going to laugh at you again because it's going to be so obvious to them that no, you're feeling the equal but opposite reaction from the matter you're stuck on. It's pushing back. Dope.
An observer confined in an elevator having an upward acceleration of 9.8 meters per second squared.
Right, and then that's the exact acceleration that the Earth is pushing back with. So that's exactly what you're mimicking, is the Earth pushing. The floor of the elevator is just going to duplicate what the Earth is doing, which is it's pushing back, and gravity doesn't have anything to do with this.
Would not be able to devise a test to see if he or she is accelerating upward?
Yes, because it's exactly the same circumstance. There's only one force involved. Okay, there's the force back, up, 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 up. The physical force you're feeling. That's the only one that matters. And so the floor of the elevator is exactly like the Earth because it's one force pushing you in a direction. That's it.
Or motionless, but in a gravitational field with the same downward acceleration force. Every effect of gravity is reproduced exactly by an upward acceleration.
And again, it has nothing to do. There doesn't need to be anything called gravity. The pushing up is all you need. All right. Now, obviously, we're not being pushed up so we fly. So we're not flying against gravity. We're just being pushed up enough to equalize the condition. So we're in this, we're bouncing essentially. Well, that's why the whole relativity thing, our clocks move slower, is because we actually have more velocity because we're bouncing very fast. Where a satellite up in space is bouncing much slower. So if I bounce the basketball slowly, it travels less distance. I bounce it quickly, it travels a lot more distance. So its velocity is obviously much higher. The faster I dribble the basketball, the faster the basketball is actually moving through space-time.
And the reverse also holds true. Through this view, if a transmitter is located...
So this is so bad, I don't even know how to say it's so bad. It's so illogical. It's such a pile of crap. How can anybody believe this? It's so bad, but I love that he's using radio wave, kind of metaphors, because it just makes it so obvious how wrong this is.
Located at the bottom of our elevator, and a receiver is at the top, then a shift in wavelength should be observed.
Why? See, the emitter's moving in one direction, the receiver's also moving in that direction, so everything the emitter's doing to compress the wave, the receiver will do receiving the wave. So there should be no change in the frequency. It's illogical to think there's a change in the frequency. There's absolutely zero reason for it. There's only the velocity of the antenna and the velocity of the receiver. There's nothing else in the equation, therefore no reason. Okay? In this connected wall spaceship. Now, if you just had the emitter and that was the only piece you moved until the emitter crashes into the receiver, then you can expect a change. But as long as the receiver is moving the same speed as the emitter, this experiment is doomed. This is, again, you would go to the aliens with this stupid theory where you just ignore the fact that the receiver is also moving away from the force. I mean, it's so bad. So this is where they take something Einstein said that I don't even think Einstein would agree with this. So I think they have taken what he said and really screwed it up.
In the elevator, the radio waves will be traveling upward towards the ceiling, but by the time they arrive to the ceiling, it will have moved farther away.
Yeah, that's right. It would have moved farther away and is still moving while the waves are hitting it. So like me running away from the ocean waves, I'm going to change the frequency of the ocean waves. As I'm moving away from them, they'll hit me with less regularity. Well, the receiver is going to take the compressed waves, and it's going to expand them again, if you want to look at it that way.
And because light speed is constant, it still has to arrive in the same amount of time.
Right, so they're breaking the laws of physics here, in the sense they're saying somehow it moved more distance, and that's a fact, right? In this theory, the way the light has to it has to travel more distance, because at the point it was emitted, that's where you say go. And now we're going to figure out how much distance till it hits the receiver. Well, the receiver is moving away from the light, so we know that the light is going to have to travel more distance to get to the receiver. It can't get there in the same amount of time. See, and this is where the Einstein thing just totally breaks logic. There's no way that happens unless you're saying light can move faster than the speed of light, because the faster away I move that emitter, okay, this doesn't have anything to do with frequency now. It just has to do with you started the impulse. The first tiny bit of an impulse came off of something. The fact is that the emitter, if it's moving half the speed of light, I'm going to create a tremendous amount of distance between me and that thing moving the speed of light. There's no way it can get to me in the same amount of time, because I'm moving the hell away. By their theory, right, if the universe is expanding and I'm 15 billion light years away, way out here, and I'm moving away from you really fast, by their theory, it should only take 15 billion light years for me to communicate with you, even though you're moving away from me. That's how illogical it is. It can't be sustainable by any kind of logical reasoning. This is nonsensical mush.
With the observation of the speed of light always being the same, the only
So again, the observation of the speed of light always being this. No, it's not the same. Okay? It's just not. That's a whole perception argument about what happens and you change perception and all of this other nonsense. We're talking about physical objects and how fast light can move from traveling through space. And there's absolutely no reasoning that could possibly defend that I can move something away and it's the same amount of distance. It's impossible to say that. I made more distance, but it's the same amount of distance. It can't be the same amount of distance.
observable effect of this movement is within the expanded wavelengths, the redshift. The exact cause of this supposed shift is more complicated than I'm able to explain.
Yes, well, it's silly is what it is, okay? Your theory of space being created that stretches the wave, there's space filling in this wave. It's filling it in with more space, so more space is filling in here. And somehow, though, it can fill inside of a tiny photon nanometer, right? We got this tiny little 300 nanometer photon, right? This little tiny distance. And space can get in there, but it can't get inside of atoms, and it can't get inside of all this other stuff. So it's not expanding them. It's not expanding the distance between your atoms. It's not expanding the distance between the proton and the electron. It's not expanding all the other places space is. All of that space isn't somehow getting expanded. I mean, it's just dark matter. This is a silly interpretation of the situation. This is just blaming the invisible man for the murder. It's just as preposterous as the alternative OJ theories. It's just nonsense.
But let's just say that it has to do with gravity, speed, and the effects that they have on time. Maybe another video on that someday.
Well, I mean, you're just going to embarrass yourself, in my opinion, okay? You're going to make a permanent record of you talking bullshit and deluding poor little children and things. You're just going to corrupt their brain with a silly little Jesus story, because the credibility of this theory is near zero. I mean, the evidence is so thin and the claims are so extraordinary. This is just such bad science. And what the fuck is this stupid pancake guy doing on this video?
Either way, Einstein postulated that in a gravitational field, you would see this shift in wavelength as equivalent to what you would observe in the elevator.
Right, well, I'm just saying, obviously it's nonsense. You make more distance, it takes longer for the stuff to travel the distance. It's just a fact. Blah, 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 blah.
The shift in the wavelength of light would be so minute that it would be almost unobservable.
Yeah, well, that's the whole argument with scatter, okay? The amount of scatter, Compton-type scatter of photons through atmosphere through lots of things. It's a tiny degrade, but obviously over hundreds of billions of light years, that little tiny bit could add up to a lot.
Now comes in Robert Pound and Glen Ribca. In 1959, Robert Pound and his graduate student Glen Ribca
61 years ago.
proposed an experiment that would be the last of the classical tests of general relativity.
The last one? I don't know. These are classical tests, so again, they're always testing the same kind of nonsense. Distance doesn't matter theory. Again, it's all just based on clocks and understanding that atomic clocks are different than Timex watches and are different than sundials, are different than they're all different. Hourglasses, sundials. There's no such thing as a sundial.
And it used an ingenious setup. The problem with measuring redshift due to gravity is devising a way to measure such minute changes. Measuring the redshift over an elevation difference of 22.5 meters would require being able to observe a change equivalent to 2.5 times 10 to the negative 15th change in energy levels.
Right, which isn't easy to do now. And in 1959, again, I've made an analogy. I was born in 1959. Even when I was 10 years old, you couldn't buy a watch that you didn't have to set every other day.
Meaning that very, very short wavelength photons would be required. Pound and Ribca identified iron-57, which emits 14 kiloelectron volt gamma rays during transition between its states. This also means that iron-57 will only absorb gamma rays at exactly 14 kiloelectron volts.
So this whole argument of it'll only absorb is based on their understanding, like somehow it rejects it, the energy hits it and somehow doesn't affect it. It's still getting absorbed, that is, it's still going through a process. So, blah 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 blah. There's lots of assumptions made in all of these experiments about what's actually taking place. Again, when they talk about entanglement, all the entanglement experiments are done with light polarization. They're not using some quantum property that they're actually measuring. They're measuring polarization, and they don't really understand it. So, how can you trust them?
Fraction more or less energy, and the photons would pass right through the atoms. This wavelength...
It won't ever pass right through the atoms, so that's just bullshit. It can't just pass through. Okay, it can be readmitted some moment later, but it'll get scattered, right? Even that argument, right? It'll get scattered.
Is 86 picometers. The researchers placed a gamma ray source at the top of the Harvard University Jefferson Laboratory building, with a target block directly below it, 22.5 meters away. To create this path, they literally had to cut holes in the floor from the roof down to the basement. The travel space was confined.
Yeah, it's really not that big, right? So we're not talking about, frickin' Empire State Building or something, which would be a little bit more impressive. It would cut that negative 15 number down to negative 10 or something.
In a helium-filled mylar bag to minimize scatter.
All right, helium-filled mylar bag. So that's what this is, right? So it's full of atoms. So let's understand, they didn't do it in a vacuum. No, they just decided, well, we'll take out all the dust, we'll take out all the big particles that'll scatter the fuck out of the stuff, and we'll put in a nice clean gas. But the nice clean gas is still gas. It's still molecules. It's still atoms. And you have to force your gamma rays to travel through them and by them and in them. And so the logical argument is those atoms also have a momentum based on gravity, right? Which way are they going, right? Because you can make both arguments. That somehow if I let that bag loose, it would go up, which means there somehow has to be more force inside the bag going one way than the other way, unless you want to say no, it's a buoyancy argument and the atmosphere is pushing it up. But either way, that means there's more molecules either at the bottom or there's more molecules at the top. And the fact that there's more at either the top or the bottom means that there has to be more energy pushing them there. If they're at the bottom, they were pushed there. If they're at the top, they were pushed there. That means they're moving in that direction more than they're moving in the opposite direction, which means they have a momentum in a direction, which means the whole tower of helium has a direction built into it that has nothing to do with gravity directly, but has everything to do with what you would anticipate would be the scatter effect of the difference between hitting an atom moving opposed to your direction and hitting an atom moving in the same direction as your direction, and that those two things might be quite different. One might cause a lot more shift than the other.
And a photon counter was placed below the target sample. If there was no redshift, the target block of iron-57 should absorb all the photons emitted from above, and the counter should remain at 0. But if there is a gravitational redshift, they should pass right through and register on the detector. And when they turn...
All right, pass right through again. That's their theory. So they're telling you that somehow it passes right through. Like the bullet, if I make the bullet go fast enough, it goes right through me and it doesn't break anything or cause any trouble. So that's kind of bullshit, right? We know that, yeah, it'll change how things happen. The slower the bullet, the more it tears and rips and all that stuff. So a slow bullet is sometimes more lethal. But the point is that those differences are real. They're not fake. So you can't just imagine that, oh yeah, the frequency's too high. It just magically shows up on the other side. That doesn't happen.
On the counter, it did register. Pound and Ribca observed the gamma rays passing directly through the target block and registering on the detector. This confirmed that the photons had been shifted due to the elevation difference in the gravity well. To further confirm the results, the emitter was...
So again, it's not as simple as this animation, blah, 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 and what this part just doesn't make much sense. So you've detected gamma rays because they got through a medium you said would be 100% absorption. And now, what? So,
placed on a loudspeaker. By vibrating the speaker between 10 Hz and 50 Hz, the emitter rhythmically moved up and down, forward and away from the absorber, varying the Doppler shifts created by the speaker cone. Pound and Ribca observed that at specific frequencies on the speaker, the Doppler shift canceled out the gravitational blue shift, and the receiving sample absorbed the gamma rays.
So a minor movement, okay, is going to change the frequency. So that's consistent with what I'm arguing. But the fact is that the whole experiment is suspect just because this assumption that these gamma rays are unmolested by this path is a wrong assumption.
This absorption correlated directly with the vibrations of the speaker. They also reversed the source and target and observed the exact same magnitudes of frequency shift, only in the opposite signs.
Well, again, so how can you observe the same frequency shift when your frequency shift is based on the fact that now the opaque thing isn't opaque? So you first argue that it's opaque to a certain frequency and you get no light, right? No gamma rays get through. And you're saying, well, the frequency was changed so gamma rays got through. Well, you can't reverse it and say, well, there was no gamma rays and then there was double no gamma rays. I mean, that doesn't make any sense. You can't argue that, oh, well, there was double zero. No. So there's something flawed in this logic right there. But I mean, obviously I would argue that the helium atoms in this tower are not just sitting there saying everything's just fine. No, they are either being pushed by gravity down or their motivation is up. But their motivation isn't nothing. They don't have zero motivation. They have motivation. And their motivation is a reflection of gravity, and therefore, but it is not gravity itself that's causing the effect. It's helium atoms.
With this simple and ingenious experiment, Pound and Ribca confirmed Einstein's predictions in general relativity to within 10%.
Well, 10% isn't very good, frankly. But regardless, there's nothing to say. They engineer experiments, they get results that they like, and then they publish them. Now, the Young experiment's been around for 200 years. the drawing of two waves coming out of the double slit, it doesn't work mathematically. Completely incorrect. Okay? The only way you can make it work mathematically is to have either infinitesimally small slits or an infinitesimally small impediment. But unless you make those things mathematically smaller than a wavelength of light, it will fail to predict the right pattern. You can't use two waves and get the right pattern. 200 years now, that broken piece of garbage as an experimental analysis has thrived and is just recited over and over and over again by physics. And they talk about how they have all this precise math and they've precisely done all this stuff. That flaw has existed for 200 years and they've done nothing. Not a single one of them exercises any pause in telling us that's the truth. It's convincing evidence. It's horrible evidence. And I would argue that analysis here will get you probably to the same conclusion. That although this appears on the surface to be, oh yes, that's pretty convincing. No, pick at it a little bit and you'll find out it's very unconvincing. There's lots of alternative explanations for the change in the shift of the change in the frequency of the gamma rays.
Gravitational redshift was no longer a fanciful idea. It was experimentally proven to be...
Okay, so again, they say this is a proof. They say they know what a gamma ray is, they know how to receive one, they know all this stuff, and you know they don't know any of that stuff. Again, they can't even account for simple things like polarization. How can you trust them with these words we've proven? No, you haven't.
Reality. I hope I've been able to convey the absolute genius of this experiment.
Okay, so again, the genius of what? And wouldn't it be more genius if you could demonstrate with another experiment or show, like I said, we don't even have a video of this experiment. You have a few pictures and that's it. And you say, well, we've already proven it, it's established fact, there doesn't need to be any more discussion, blah, 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 blah. Gravity affects light. And it's a terrible theory. Again, if you went to the aliens with your, we can bend light with forces, I think you're going to get laughed at pretty hard, because all the aliens know you can't do that. You can't affect a force with a force.
When I first read about it, I was mind blown. With minimal specialized equipment, two researchers...
I don't know. It's, gamma ray detectors and all of this kind of stuff, that's not exactly minimal, but whatever.
With nothing more than determination and ingenuity, were able to measure something that others thought was immeasurable.
Right, and Eddington did that, and nobody ever repeated it successfully. So isn't that sort of the joke here? So you have an experiment that apparently no one's repeated, and yet, you're claiming it's rock solid, and they're great science. Now maybe it's rubbish.
This experiment inspires me.
That's unfortunate. What should inspire you is, I don't know how to even say this, is that here we are in this pursuit to understand the world, and you're accepting as a bunch of explanations this wooey, crazy, silly stuff of particles that split into two and things that aren't where they're supposed to be, and they're in 14 different places at once, and the past and the present and the future are all in some place somewhere. I mean, it's just so silly.
Right here. This is what science is. And I hope that it inspires you.
I think scientists should be inquiring, but when they draw hard conclusions, then that's not what science should be. Science should be, well, let's evaluate, let's understand it, let's pick it apart and see if it really adds up. And you never did any of that. You just make declarations. We did it. That's what we get. We get LIGO declarations. We did it. You can't possibly reasonably doubt us. We say so.
As well. And my question to flat earthers and to science deniers?
Yeah, those aren't the only two categories. There's lots of people who are just saying, your explanations suck. Okay, I mean, bent space is silly. Virtual photon, that's baby talk. You can't explain how a magnet works. You can't explain anything. Your theory, dark matter, again, it's laughably God of the gaps nonsense. I mean, to call somebody a science denier because they say, that's junk science. You're just making this crap up. You're just saying, well, what kind of weird character can we shove in between Jesus and God? Let's see. Because we need a third character, right? There needs to be a threesome here. So let's create a Holy Ghost and shove him in between, and we'll let him do some silly thing. I mean, the whole thing is just silly. It's a silly religion.
If you believe that gravity isn't real, then redshift isn't real.
Well, again, gravity isn't real. I don't think any of them are saying gravity isn't real. They're saying it's being caused by something, okay? And the something isn't bent nothing, okay? The something has to have energy in it, clearly. There's an energy formula for this thing, okay? It doesn't come from nowhere. There's no magic, just come to me. Electrons aren't just sitting there in space going, I'm an electron. Oh, the space is bent. I have to go that way because the sign says so. I mean, it's too silly.
Real. And this experiment isn't real. And this experiment...
So you're just straw manning the argument. The argument is that there's a lot of your physics that's very weakly evidenced, insanely weakly evidenced. And you're claiming no reasonable person could deny. And what I'm claiming is every alien in the universe would laugh his ass off at you, okay? Because your evidence is so bad, all right? You jump to such wrong conclusions based on such little evidence that they would just mock you as silly, stupid organisms. God, they just can't grow up. They can't get past being religious kooks. They just keep making up God theories, all right? And they never got to really doing physics. They never said, let's do real physics instead. Physics that has physical objects in it, and the objects have to have actual properties, and they have to do actual things, and they have to be accountable. They can't just poof into existence and then poof out of existence. That those are silly answers to the questions.
It is reproducible. This experiment is reproducible by...
Well, why should it? Yes, why don't you reproduce it something even better? And again, we've reproduced the double slit experiment millions and millions and perhaps even billions of times, and every single time you lie about what the results are. You make up a fake story about two imaginary fake little waves and two imaginary fake particles that can't possibly create the right answer. They can't possibly do it. There's no theory where the two particles can create the pattern. It has to be four particles, actually. It was always the two surface experiment and the four surface experiment. You didn't even figure that simple fact out.
Such as me, if I was determined enough to get the equipment to do it, and maybe someday I will. But if you want to stick behind...
How special will that be? You have to get a partner, though, with a silly name.
Behind your beliefs that gravity isn't real and all science...
So again, just more crap. All science, that's not... There's lots of dissidents who are just really dissatisfied with what sounds like a religion. That's all. I mean, look, you turned me right off, right? When I was a kid in whatever, 8th grade, 6th, 7th grade, I think it was. And they drew that silly frickin' drawing of a photon on the board, and my brain just said, yep. These people have no credibility. Just more examples of stupid human bullshit. I mean, they're not even close to the truth.
Just fakes everything? Prove it. Reproduce this.
No, you prove it. You actually produce some evidence for a change. Some real evidence, okay? Don't keep showing me galactic images that don't make any mathematical... Look, it's an Einstein ring. Well, except it's all crooked and it doesn't make any sense. It can't mathematically be defended as one of those, but that's what we're calling it. I mean, your evidence sucks. So, and again, I have proven it. In a sense, I've proven there's alternative theories. I have an alternative theory of the creation of gravity merely by absorbing force in the universe, and that's just a fact. You slow the force down, you force it to push matter. Pushing matter means the force moves slower than the speed of light, means that, there you go, you have a deficit now. And that deficit is what will be felt as gravity. Obviously, but you won't feel it. Okay, you won't never feel the force of gravity again. You can only feel forces that affect you unevenly, not forces that affect you evenly. If I pushed you to the speed of light with gravity, you'd never even feel it.
And prove it.
Okay, well, again, your definition of proof is pretty crappy. So I guess all I have to do is finance an experiment and I'll say we did it. And until you prove I didn't do it, I did it. Oh, that right. It won't work, right? Because the only way I can do that is if I have some credibility. I have to come to the table with a reputation like Eddington or somebody like that. And then the New York Times will say, yeah, Einstein proven right. But it won't say it if I do it. Again, I can show you the two-slit experiment. I can show you, like I said, I can show you the pattern, and I can tell you I can find no theoretical way that two waves produce that pattern. There's no way to draw them. There's no way to mechanically understand them. Two vectors won't work. It can't do it. And your response is nothing. Alright, so that should be enough of a video. There'll be a commercial next. I really don't like this thing, whatever it is over there. I don't like it. Creepy. Anyway, so till the next time and such, and so forth and whatnot. I can only reason with you people. Again, I mean, you're just so unreasonable. I can't bribe any of you to defend this crap. I mean, it's just so depressing living on this planet of scummy cowards. That's what most of you are. God, you assert things and then just run away. Everything about you, your politics, everything is just so fucking ignorant. Ugh, it's terrible. It's such a fucking dumb planet of dumb organisms, still covered with just dumb animals. Sadly. Okay, this isn't the thing I need. I will hit the button. Oh, I should have hit this button a few times. Yeah, I should have done this thing a few times just for fun. Yeah, just for fun. Alright, anyway, till the next time and such.